from there. Okay. Okay, let's look at this one now. So as I said, there is a fourth and a fifth and a BCNF normal form, but we are kind of sticking to 1, 2, and 3. Okay, so that's enough information for you from programming point of view. But that's not the end of it, right? That's not the end of it. So even being aware of something and understanding it is a concept in itself. Okay, so let's look at this one. It says to create a database and tables therein. All tables are in second normal form, but not in third normal form. We'll look at the definition in a minute. So again, I've created a database. I've created books inside it. I've just taken one table. As I said, I'm keeping it simple. Look at what is inside the table. So this is about books, right? So there is author information. That is author, the name of the author, the title of the book, the publisher ID, the publisher city, and then the primary key is again author and title, because that combination is always unique, right? The same author will not write the same title. It will be something different. Edition 1, edition 2, something will be different. So you can't have the same author, the same title. It cannot happen. So since this combination is unique, I've made it as a primary key. Again, why am I trying to do this instead of auto increment? Because both second and third normal form depend upon a composite primary key. Even in the second form definition, if the primary key is a single field, automatically the table is in the second normal form, because you only talk about partial dependence when there is a composite key field. So therefore, to keep my primary key fields composite, more than one field, I'm choosing these examples. We could have made an auto increment primary key here, but again, as I said, and as Ben was also asking, what is the norm? There is kind of no norm for if as I said, if you don't need, your application doesn't need to access records using the primary key, don't bother about it. Go with an auto increment. But again, keep in mind the second normal form definition said every non-key depends completely on the primary key. So definitely if the primary key is a single field, the table is already in the second normal form. So similarly in third, if I do not have a composite key, then the definition will not hold. Okay, so now let's look at what is the third normal form. So a table is set in the third normal form if it is already in the second normal form, which means it is already in the first normal form. And every non-key field, again, please, you can add this. So what is a non-key field? A field not part of the primary key. That's what a non-key field is, right? Now let me say what is this non-transitively dependent in a minute. Okay, now let's look at the table. So author and title are the primary key. There are only two other fields in the table. Publisher ID, kind of an odd name. I should go with publisher ID and publisher city. These are the only two non-key fields. Okay, so we have to concentrate on these non-key fields. Okay, so there is a publisher ID and there is a publisher city. The publisher ID is basically the identification of the publisher, and the city is the city where the publisher company is, right? Now, something doesn't seem right. Let's look at what the problem is. In the previous table that we did in the second normal form, the store address was dependent upon store ID, right? And store ID was a part of the primary keys. But what is different here then? Publisher city is dependent upon the publisher ID. It is not dependent upon the key at all, right? It's not dependent upon it's not dependent upon the key at all. It is non-transitively, indirectly dependent upon the key. So publisher city is dependent upon publisher ID. Publisher ID is dependent upon the key. So you see the transitive relation. There's not a direct relation. There is an indirect relation. This is called non-transitive relation. So what am I saying? A table is in the third normal form if A, it is in the second normal form. We're already there. That's done. And there is another condition attached to it. Every non-key field is directly dependent upon the key. It's not indirectly dependent. And here we see that publisher city is dependent upon the publisher ID and publisher ID is dependent upon the primary key. This is called an indirect or a transitive relation. So we want every non-key field to be non-transitively or directly dependent upon the key. So it's a little different from second normal form. They were talking about partial dependence upon the key. Here they're talking about indirect dependence upon the key. So that's not a table in the third normal form. You'll say, Any problems? Can't we keep it like that? Same problems. You will have duplicate data. You will have replicate data. This information that this publisher ID relates to this city, why do we need to keep in this table at all? Right? Because you'll see duplicate data. You'll see the same data many number of times because the same publisher may be publishing many books. And again, if there is a publisher who's not publishing books about anybody right now, or maybe of this author or title that we are talking about, I can't keep that information anywhere at all. But if I have it in a separate table, then I can keep this information that publisher ID 1 is related to this city, 2 to this city. I can add a new record, 5 related to another city, without that publisher publishing any book right now presently. So I can keep that information. And of course, if there is no duplicate information, there are no problems in update and no problems in delete, right? Redundant data will always cause problem unless that redundant data has been put with an intention there. Like I said, BMO, for example, the banks, large banks will do this. They will duplicate their data, not in the same database, of course, right? But they will duplicate their data at different locations so that if their data center burns down or something goes wrong, at least they have their data somewhere else. But this is intentional, right? This duplication is intentional. But duplicating data inside a table is a big no-no. Doesn't make sense, right? Because remember, anything that is duplicate, there will always be problems of doing updates and deletes to it. The data could be inconsistent at a certain point of time. Okay, so again, what will I do? I will take this table, I will split it into more than one tables. No information must be lost, but I'll keep information that is in the third normal form in one table and also in the third normal form in the second table. So logically, what should I do? I'll take the pub ID and the pub city and put it in another table. And I'll take the author, the title, and pub ID in another table. And definitely, I'll have to see what the keys will be, what will be the constants, and so on. As soon as you start splitting tables, there will be the question of foreign keys, right? Foreign keys, as I said, is a value which will depend upon values from another table. So definitely they will have to think about it. So right now this table sits like this. I've said when is a table in the third normal form. I've said here the dependent on publish ID, which is further dependent on the primary key. If you really want to, when I'm talking keys, I'm just meaning primary key. Though I'm sure if you've heard it in another course also, there is something called a candidate key also. Candidate key simply is another candidate for the primary key. That's what a candidate key is, okay? A table could have more than one primary keys. Sometimes it is even difficult to find a primary key, but sometimes a table can have more than one primary keys. And in those cases, you make one as the primary key and the other are called candidate keys, right? They're just candidates for primary key. Therefore, they're called candidate keys. Okay, so if just because John Wang was asking me what is a candidate key. So here is some data, but notice what I've done. In the last two records, do you see? 1 and 1, New York and New York. Data is repeated, right? So duplicate data because New York is related to 1, New York is not related to the name of the author or the name of the book. It's not, right? So what will we do? So of course, this one will run. There is, I mean, it's not in the third normal form, but it will run. There is your data. And what I'll do is I'll again split this table into more than one tables. And I'll split it in such a way that information is not lost. You will never lose information in a table. You should never. So I'll split it. I'll ensure that all my tables are in third normal form. I'll redistribute the data so that when I combine it back, I can have all my information. Okay, so let's try that now. So the last one, the third normal form. So I'm going to save it as the third normal form, just so that I have all my files. I know where I started. Okay, and then save it. And now let's do it. So you can, again, if you like, you can take the definition of this, a table is in, and just put it in the, just so that you have it. And of course, we will now convert it into all in third normal form. We'll do it. So once you do this, all your tables will be in third normal form. Okay, so let's see what can be done. So one thing that I have to definitely do is remove this publisher city from here, right? So let's remove it. And again, if I need to rename it, again, whatever you like, remove it. So let's not, I'm not going to remove, I'll just keep it here because I know I'll need it again. Okay, so that's my first table. Now let's look at it. Is it in the third normal form? It's in the first normal form. It's in the second normal form. So the only non-key attribute that I see is publisher ID. Does publisher ID completely and directly depend upon my primary key author title? Yes. So it is in the third normal form, right? That's how publisher ID is related. Okay. Just because I'm telling you that's how it is related. So that table is fine. Now create the second table. Create the second table. What will go in that second table? The pub ID and the publisher city will go in that table. Right? Same concept. You always, whenever a particular table is not in the normal form, you will have to split that table and split the information. So definitely starting right from day one is the rule. Altering your table afterwards, doing all this stuff, removing data and everything is a big job, time consuming, unnecessary, time wasting job. So keep that in mind. But anyway, since we have to learn how to do it, we are doing it. But that's something that you have to keep in mind if you decide to become a database programmer or designer. Right? So this is something you must know. Okay, so let's try. So let's create the second table. And then, of course, if we create the table, we'll have to think about it. Okay, let's go one at a time. Oh, we'll have to do this same mistake again, because if there is a constant, that table has to be created before. So I'm going to drop a table. What do I call it? Publisher. I'll just call it publisher. Right? If exists, don't forget your if exists. If it does not exist, you will get an error. If it exists, then you're okay. Okay, let's create the table. Okay, so let's create the table. Start and end. Okay, let's put the two fields in it. We have a publisher ID int not null. And since we already have them, now you see, because you already have data, you can make it an auto increment key. You have to kind of follow the same rules. It's an int, it's a not null. And the second field that you will put here is the one that we copied from here. Okay, so let's put it here. So this is my publisher table. Here, this is my publisher table. What is your primary key in this table? You don't have to say not null if you make it a primary key. Keep that in mind too. You can, but you don't have to. It's its default definition. Remove your comma. Here, there's, I've created my first table. Right, so my first table, I've called it TBL publisher. You can call it whatever you like. I've put a publisher ID, which is an int and is the primary key of my table, and a publisher city, which is varchar 25, not null, same definition that I had in the other table. Let's look at it. Is it in the first normal form? Definitely. Right? Second normal form? Yes. Third normal form? Yes. Right? So this table is in the third normal form now. This table is complete. Let's look at the second table. What are we left with? We are left, again, if you just want to be like consistent with your dashes, you can do this. Though to me, it doesn't matter, right? And we are going to put data anyway, so we are okay. Okay, let's look at this one now. We have, is it in the first normal form? Looks like every key is atomic in nature. There is a primary key. There are no repeating loops. Is it in the second normal form? Pub ID is the only non-key. Is it dependent fully on author and title? Yeah, it is. Okay, so that's done too. And then 3, every non-key field, that's only publisher ID, is non-transitively dependent upon the key, directly dependent. Yes, my job is done. But what is missing? Now that I have my publisher ID in another table, what will I have to do here? I'll have to add a constraint here, right? Because this publisher ID has to come from the other table. So as soon as you split and you start making relations, you have to make relations, right? So I'm just going to just tab it a little so that, oh, what happened to my, oh, well, where are you not in third normal form? I did a Control-Z, didn't get it back, which is strange, but anyway. So I'm just going to copy the whole thing and then bring it back. And again, the name, just if you want to do it. Maybe it will be more work. Okay, what isn't it like? Okay, we don't need the publisher city here, but we definitely need a constraint here. There. Okay, let's put the constraint now. Same concept that you've learned in other tables. You'll put a constant. So put a constant, please. Call it whatever you like. I'm calling it C1PK. Oh, C1FK, sorry, because it's a foreign key, right? And what's the constant? The constant is that this is a foreign key. What is the foreign key? Publisher ID is the foreign key. Okay, what can it refer? It can refer, it references, did I make a mistake? It references the, what was the table name? TBL publisher. And what does it reference from there? The pub ID. And a comma. Why do I have this red squiggly here now? Create table books. I have one here also. Let's do a save. Oh, that's a comma. That sure is okay. That makes sense. One gone. What's drop table effects is semicolon create table. I don't know why it doesn't like what it doesn't like. Oh, do I have some? Oh, looks like I have something here. Oh, there it is. Ah, it all the time it had just there was a plus and I didn't even notice it there. The table was already there. Ah, of all the things to have. Oh, let me do this one just because it's easy. So pub ID has something. So let's go till here. There we are. That's why the control Z I couldn't see it just because it was not visible. There it is. Now, there. Okay. So don't forget your constraints. Constraints are something that you'll have to kind of take care. So table publisher ID, and primary key. There, that table. Let's look at it now. Is it in the first normal form? Yep, it's in the first normal form. I have a key. Yes. I have non-atomic fields. Yes. Is it in the second normal form? Definitely. Publisher ID is the only other field which is directly dependent upon the complete field, and also it is non-transitively dependent. This table now is in the third normal form also. Job done. Now the next job is to split your data, right? So it's not only restructuring the table or splitting the table, it is also splitting the data. This was your data. How will you split it? So these three should come together, right? Because there is where we have done, and then the 1, 2, 3, 5 should come in a different table, the publisher ID. So notice we have a 1, we have a 2, we have a 3, and we have a 5. Okay, so insert here. So populate your data. Insert into the table TBL publisher. What do you want to insert? Values. And we had a 1, we had a 2, we had a 3, and we had a 5. That's what we had, right? So again, if you, whatever you would like to call it, publisher or publishers, whatever you've done, just follow. If you've done an S, do this, right? Okay, 1, 2, 3, and 5. So, okay, so 1, 2, 3, and 5. Let's pick up. 2 is New York. It's just better to pick up. New York and New York are 1 and 2. Control C. Okay, so 1 is a New York. Control Z, come on. I said pick this up. Control C. Pick up. Pick up. Let's look at the other ones. 3 is San Francisco and Boston. Actually, this work that I'm doing right now with all these copying and pasting, that's not how you do it. You will write, you'll have to update your tables and extract values and put them in new tables. That's a lot of work. Nobody does it like this. I mean, you have trillions of records, you won't copy and paste. You will create the new structures, and then you will write update statements that will select data from the original table and populate the 2 tables or 3 tables or whatever tables you do. And that's not easy work. If I give you something, it will take you almost 4 or 5 hours to do it. It's that tedious. Even with a small table where you can see all the records and you know that's what it is doing. I tried it with the My Contacts that we did, the first example that we did in class. Right? In that class, I said, give me your favorite sites. So I just had a bigger table. I just created something and almost 4 hours of work to put all the data and ensure that all select statements were right, everything was right. It takes time. I mean, copying, of course, we are not going to copy in the real world, but in the real world, we still have to distribute the data. And how will you distribute it? You will select it from one table, put it in another table. Your constraints have to match. You will have to break up data maybe into parts if it is not in the first normal form. And if you start with a table which is not in the first normal form and kind of start splitting data and all that, it takes time. It is tedious, okay? So whatever it is, it's not the right approach. You start wrong and it will take you time to fix it. So fixing problem takes more time than starting right. Keep that in mind. A programmer, if you design it well, you're okay. Okay. So let's see if this table is ready. This table seems to be ready. So we have 4 publisher IDs, 1, 2, 3, and 5. These were their cities that I picked up from the data, and the rest of the data I'll remove it from there. Okay, so my one table is ready, right? I've created a new table with a new structure, and I've moved the relevant data from there to here. The primary key of this table is publisher ID, and this is being referenced in the other table as a foreign key from the foreign key field. There is no rule which says that the field names have to be same. Now, please do this. Take your second table and from everywhere remove your city. And of course, if you try to add a record that does not, a city that publisher ID that does not exist, it is going to give you an error. I mean, that's logical now. You can't put in a foreign key says you can do that. Okay, so that's insert into table books, and we have how many fields? 1, 2, and 3. 1, 2, and 3. Right? You don't have to, but if you want to, you can give your list here. So this was author, title, pub ID. Oops. I mean, you can. You don't have to, but you can. So of course, you'll have to look at it, right? Author, title. What was the last one? Pub ID. You can give your list if you want. There. Data is split now, right? So you can do a select all from here, and you can also describe your first table if you like. Oh, remember I called it underscore and underscore. If you didn't, that's okay. Just again for consistency, nothing else. The other table had an underscore. I mean, you can do it or you don't. Okay, so we'll take this describe again. And since I've created a new table here, I'll do it here too. Except that this table is called publisher. So do a describe of the publisher and do a select all of the publisher. And there you go. Anything missing? Looks okay, looks okay. Insert into table. I have a red squiggly here. Looks okay to me. We'll know when we run it. Okay, my table has been divided, right? Both the tables are in third normal form. Let's try it. 4. Okay, so that's my first one. Notice no primary key, yes. That's my second one. That's the contents of the first table. That's the second one. It's a primary key. So if you see primary in front of 2, that means that's a combination. You can't have 2 primary keys in a table. A table can only have 1 primary key. The others are called candidate keys. But you can't put primary key in front of, like you can't say, oh, this is combination is also primary key. This combination is also primary key. More than 1 fields can be a primary key, but they're all together taken as one. So I could, if you like that concept, instead of writing it separately here, you can put the word primary key in front of both of them. But it assumes when you have it in more than 1 field, the combination is the primary field. I like it this way because it makes more sense, but you can put it in front of both the fields. But it still means, it doesn't mean, oh, this is also a primary key and this is also a primary key. It just means the combination is the primary key. So whatever you feel like, it's up to you, whatever you feel like. And then this is the last table. All these tables are now in the third normal form, right? I did have another table which was not in the third normal form, but it was just more work. And I thought I would show you something simple, and then we will move on to that example. Again, now if I want to get my information back, I want to have whatever I had from the previous one, this one. If you run this, if you want this information back, you will have to join the 2 tables. From the first table, you will get the author, title, and the pub ID, and from the second table, you will get the pub city. But you'll have to say the condition. What am I matching? How am I joining my tables? So you will be joining them on the pub ID because pub ID is the common field in both the ones. And that's what we have to learn next. Once we have our tables, and we will now work with more than one tables in a database. Once we have our tables, and now we want to extract information, how will we change our select statements? And there is where you learn joins, right? So how do you join more than one tables? There are three types of joins. One is called Cartesian product, one is called inner join, one is called outer join, right? I'll show you all three, but at the end of the day, we'll only mostly be working with the inner join. That will be our main emphasis. Outer joins are available, and I'll show you examples of how to work with them, but you'll notice that Cartesian product is kind of useless. Cartesian product just says take everything from the first table, combine with everything in the second table. Just a product, like multiplication. Okay, so I'll show you now. I'm going to pick up an example. I'm going to create, it's already in the third normal form because we've learned how to do it. But again, from theoretical point of view or from assignment point of view or exam point of view, you should know how to break up a table into more than one normal form. And if you want it to do as a practice, I have an assignment here, right? I just can't give you time in class to do it. I can't. I just can't do it with the Monday section. I have to rush you anyway. So maybe you'll have another assignment that you will take home, and the other section will do in class. But I'm hoping that you will all do it as the instructions say. So with joins and subqueries, now that you are, I'm hoping you know your selects and updates and delete. Maybe in joins and subqueries, I'll allow you to work in pairs now. You could now work in pairs and kind of put your head together. One, because it is more complicated, and two, that hopefully you have your concepts. So at this point of time, usually that's what I do. The first semester half, I don't allow students to work together because they're trying to learn something, especially in courses that for me are introductory. And then in the second half of the semester, I say, okay, now go ahead and work in pairs, hoping you've got your concepts. And that's how I keep it now also. Okay, so now let's look at an example and let's look at join statements now. What are these joins that I've been talking about? So guys, it is a little different. It is a little more tough than what you are doing, but it is doable. Keep that in mind, it is doable. So one by one. Now pick up from your zip file, a file that I said was called Boys and Toys Blackboard, right? That's what you have. And I'll save it as okay, so that is just there. Okay, now let's look at what it is and what are we trying to do. So now we have a database that is storing information about toys and boys, okay, and what toys that boy has. It's kind of, again, toys and boys everywhere. So this was a table, but that was not in the third normal form to begin with. I converted it into third normal forms, and I'm already giving you this solution because it was just more time consuming than the books one we did. Right, so these were three in sequel. So I just picked up the books one because it was easier to do. Okay, let's look at what I have. I have a database. I have three tables. There is a table about toys. So what is the toy ID and what is the toy? We've seen this table before. So that's a normal table. I've inserted data into it. Okay, so one is a hula hoop, two is a glider toy. I've just put in more data because now I want to work with it. If you wanted, you could have created this as an auto increment key if you wanted. And then at 9, after this, you could have just to change the auto increment key or add yourself. Since it was already there, the data was given to me, I didn't bother to change it, right? So I picked up the data from somewhere. I haven't made it up. So I didn't bother to change it. So that's my first table. Is the table clear? Let's see. Is it in the third normal form? It's in the first normal form, yes. Second normal form, yes. Third normal form, yes. You go from first. You have to start from first because that's what it says. It is in the second and. Second one says it is in the first and. So this table is in third normal form. We are okay. Table is ready. I'm now going to create a boys table, right? So the boys table has a boy ID and has the boy's name. Now each boy can have any number of toys. So I didn't want, you can't keep all the data in one table. With the same problem, you'll have problems about duplication of data and so on. So if a boy has more than one toys, you could have said boy name and all the toys he has. Now, again, that was not in the first normal form even. Okay, so here, this is your boys table. Let's look at it. Is it in the third normal form? It has a boy ID and a boy. Boy ID is a single field. It's not even a composite field. So it is automatically in the second and the third normal form. Remember, second and third normal form only come into existence because you're talking about completely dependent upon the composite primary key or non-transitively dependent. And here, the primary key itself is just one field. So the question of partial dependence doesn't even come into existence. Okay, third normal form, boy name is dependent upon boy ID. It's in the third normal form. I inserted some data into the table. Again, I could have taken it to be an auto increment key. I just didn't bother to. Right? I could have in both tables because I was starting fresh. I could have done it. 12 was the only thing, the yo-yo thing, which would have changed to 10, which doesn't matter in my data. Right? I just didn't bother to. Let's look at the third table. The third table tells me which boy has which toy. So each boy can have more than one toy. So this information is kept in this table. This boy has this toy. That's the only information that is present, right? So the boy ID will come from the boys table and the toy ID will come from the toys, right? Those are the two values, two tables from which we draw. I don't have any other field in this table. That's the only information I'm keeping. So this table is in third normal form. There is nothing else, right? So is it in the first normal form? Yes. Is it in the second normal form? There is no other non-key field. Yes. Is it in the third normal form? There is no other non-key field. Yes. So this table. This table actually is a very important junction table. It sits in the middle. You have boys, you have toys. How are they related with this table? So this table is very important in its own existence. Though you see, it doesn't have any information. It has very important information. Which boy has which toy is picked up from this table. So if you look at this table, and again, the table will not make any sense to you, but this is saying boy number 1 has toy number 3. Boy number 1 has toy number 2. 2 has 5, 3 has 2, 4 has 1, 5 has 4, 6 and 2. So as such, the table doesn't make sense. Now we will start making sense, right? Okay, now, just so that I could make it more complicated, I've also kept the color of the toy, right? I didn't combine it. Each toy can have more than one colors. So this is a toys color table where I'm keeping the toy ID and color in which it is available. Again, toy ID is a foreign key, picking its value from TBL toys, and this is just a normal field. Is it in the first normal form? Yes. Second normal form? Yes. Third normal form? The primary key of the table in this case is toy ID and color together, because one toy can be in red, one can also be in blue, and one can also be in green. So toy ID alone cannot be the primary key. Color ID alone cannot be the primary key. The combination is the primary key. So we've done all this in either of the two examples, one or second, that I just did with you. So I'm hoping that when you go home and read it again, you will understand it. So the table is ready. Please keep in mind, why am I what do you call it? Giving the name of my database with every table name. Why am I qualifying my table names here? Because I don't have a use statement. Notice I dropped the database and created it. Some people just don't like it. They find it too confusing, too much to type, too much to understand. It's up to you. I just want to keep you in the loop so that you see, oh, she hasn't done a use statement, and it's common. There's nothing uncommon about it. A programmer could be working with different databases, different tables. He can't keep doing, or she can't keep doing use again and use again and use again. This way, you can just qualify your table name and use, and you exactly know which table you're using. So it's a common practice. It's your personal preference. If you want to say use, then do something, again a use, then do something with a different table, again a use, it's up to you. Right? I just want you to know that this exists, that you may not give the use statement, but then it is a rule that you qualify every table you use, wherever you use it, whether in create, whether in insert, wherever you use it, you will have to qualify it. If you kind of get tired of it, start using it. So see, I started using it here just because I've shown you whatever, and then I'm showing you data from all my tables. So let's give it a go. This is how this looks right now. My first table tells you what toys have the ID and what are their names. My second table tells you what is the ID of the boy and what is the name of the boy. See here, I can take name to be a primary key because there could be 2 Davies or 2 Beavers or 2 Richies or 2 Billies. Who knows? Names are not unique, may not be unique, right? So I created a boy ID. Here again, toy ID, toy names may not be unique. Could be or could be not. Who knows? Like, who wants to think about it? So when you don't have to, when you can decide, or it's not so important that you have to look for something, then you go with the easy way. This one says which boy has which toy. So 4,1, you'll have to kind of look who's boy number 4. Richie. Richie has a hula hoop. So this is how you will look up. Richie has a hula hoop. 3 and 2. 3. Beaver has a balsa glider. So this is how you will pick up data, right? But of course, we won't do it with manually. We will write our statements to do it. And the last table says which toy is available in which color. So 5 is available in blue, in white, in yellow, 6 in green, yellow, and blue, and 9 in green and red. You'll say, what is this 5 and 6 and so on? Here they are. Right? So 5 is a baseball card, our baseball card. 6 is a Tinker Toys. 9 is the kite, and 12 is the yo-yo. Right? So all this information is now spread out into 4 tables. All the tables are in third normal form. And now let us learn how to write select statements to join this table and extract information. So I'll give you, like, first I'll kind of do it in a formal way. I'll tell you what an inner join is, what an outer join is, and what a Cartesian product is. And then we'll just do it using commas, the simplest way. Okay, but you should know what is an inner join and so on. Okay, so one by one, please pick it up from me. So you have some questions listed here, right? So we'll do that questions. I'll do that question since it is new for you. You'll kind of understand them. And again, if you have any questions, please ask as I go on. What is a Cartesian or a cross join or a no join? It is actually a no join also. It's not a join because you don't join on a condition. You just say, pick up all records from all tables and say hello to each other. That's what it means, right? That's what the cross join means. That's exactly what a Cartesian product or a cross join means. Cross says, take all records of the first table, all records of the second table. Let every record of the first table say hello to all records of the second. Then the second says hello to all. Then the third says hello to all. So basically, I have 5 records in the first table and 6 in the second. 6 into 5, 30 tables in my Cartesian product. Just because it is something that you should be knowing, will do. Okay, so this is how you write it. Okay, so let's start writing it and select. Again, the select statement doesn't change. Now, if you want to select all the fields from both the tables, we'll just say this, just because it's easy for us. Okay, from. Now, let's look at how do you form the Cartesian product. Okay, so what was the tables called? The first table, I think, was called TBL Toys. I'm just picking up 2 tables, right? And how do you say that you want to do a cross join, as it is called? You write the word cross join. And let's combine it with any other table boys, just for the heck of it. Because as I said, it's not so important, but you should just know that what does cross join do. So what am I doing? I'm joining 2 tables. Can you only join 2 tables? No, you can join 3 tables, 4 tables, whatever, doesn't matter. Join this says this. Look at all of them. Okay? So this one is showing you a no join or a cross join. This is showing you a cross join between the 2 tables, which is simply going to take all records of the first table and multiply them with all records of the second table. Okay, so how many should I have? Let's look at what is table toys. How many in table toys? Oh, we had 10, right? And how many in boys? We had 6. We'll have 60 records here. That's just a cross join. That's what it does. Give it a try. We'll do one at a time so that we only have to look at the last answer, okay? Give it a go. That's 60 records for your information. You can also always count them. Remember your count function? You can always count it. Those are 60 records. All it did was this. It picked up the first toy ID from the toys table and it said hello to all the boys. Right? Cross join. Just cross everything with everybody. Say hello to everybody. So the first one was picked up. The first record of the toys table was picked up and it said hello to all the 6 records of the second table. The second record was picked up from the toys table and it said hello to all the boys in the boys table. And so the third, so the fourth, so the fifth. And because we had 10 records in the toys table, it was 1 to 9 and then a 12. And there were 6 boys in the second table. These are 60 records. That's a cross join. Simply, hello to everybody. That's what a cross join is. Okay? So for your information, that's a cross join. When will you need it? If we need to, we at least know it exists. Okay. Now to find out what toys does each boy have using equijoin. Now joins come in a few flavors. Equijoin, where the field on which you're joining is equal to each other. So this is equal to this. If you're saying it is greater than this or less than this, it is then a non-equijoin. So equijoin means you're comparing fields and you're comparing that the values must be equal. That's when it is called an equijoin. So there is an equijoin, a natural join, and inner join. So all kind of, I'll introduce you to the terms and then we will stick to the one that's commonly used. Not commonly, I mean easiest to use. Okay. Let's do this now. To find out what toys does each boy have. The first job you will think is, which tables am I interested in? So which toys does each boy have? Where will you get this information? You want to have maybe the boy ID and the toy ID. We'll restrict it so that you can see less values. Okay, so one by one. Let's select. What do you want to select? You want to select the boy's name and the toy's name. Remember, boys coming from one table and toys coming from another table. What are the two tables now? Oops. What are the two tables now? So your job is this. Look at the question. What toys or toy does each boy have? Don't think about equijoin or anything. Just first look at the question. Okay, so what I'm asking of you is the name of the boy and the name of the toy. Okay, so these two pieces of information are in which two tables? In the toys table and in the boys table. So write both your tables here. There are many ways you can write it. I'm going to show you all ways, so please bear with me. Okay, and I'm just going to write it in a different line so that you can see what I'm doing. So this is coming from the boys table. I'm going to use the word inner join. As I told you, there is inner, there is outer, there is natural, and so on, one by one. You want to join this table with TBL toys. Okay. So at this point of time, I've decided which fields I'm interested in, and I've decided which tables I'm interested in. Now, where do you get this information that which boy has toys? Where is this information? This is the boy name and the toy name. Good enough. But where is this information which boy has which toys? Which table is that? Boys have toys. Okay, so combine that table also. You have to think, which tables am I interested in? So it's not that only the two tables from which you're drawing the values. Where is this information? This boy has this toys is coming from TBL. Boys have toys. So you're joining three tables. I'm not interested in the color. I'm not interested in the fourth table. So don't join tables just for the heck of it. Think. Boy name coming from boys table, toy name coming from toys table, and this information which boy has which toy is in the third table. Right? So you're joining the three tables. You have to join all three tables. What is the condition on which you have to join these three tables? If you just write it like this, it is a Cartesian product. Everybody says hello to everybody. That's not what you want. What is your condition? This boy that you're picking up from this table, boys, his ID must be here. Right? And this toy that you're picking up from this table, that toy ID must be here. This combination is, if this combination of this boy and this toy is in this table, then you show his name and his toy. Logically, do you understand what I'm doing? So there is a boys table only with boys information. There is a toys table only with toys information. And then there is a table which tells me which boy has which toy. Remember that third table? There. So this is what I do. I pick up the first, 4 and 1. 4 and 1 is a valid combination. I pick up 4, I go to the boys table and pick up his or her name, it's a boy. I go to the toy and I pick up the toy ID name, and this combination I spit it out of this. That's exactly what you have to do. Which boy has which toys? This is the table, which boy has which toy. But I don't want to see this table. I want to see the name of the boy and the name of the toy. So pick up a record. Go and look for 4 in the boys table. Go and look for 1 in the toys table. Pick up 3 and 2. Look for the 3 in the boys table. Look for the 2 in the toys table. So which 3 tables do you want? Boys, toys, boys have toys. right? Which fields do you want? Whatever I ask you. So I have said which boy has which toy. So I need the boy's name and I need the toy's name. So these are the three tables. Now, the condition on which you will join. What's the condition? This 4 should be equal to the 4 in the table. This 1 should be equal to the 1 in the table. Okay. So what is your condition? Your condition. Now, instead of the word where, you can use where also. But you can use the where also. Both are allowed, right? When you use the word inner join, usually you will see that on is used. But you can use on or where. You can use either of the words, on or where. On. So you are now saying on what condition. So if where seems more natural to do it, that's okay. But the syntax is on. Okay. Now, what are your conditions on which you have to join? Your conditions are that. What was the name of the table? Table boys. And your condition is that you should be picking up the boy's ID. Not boy ID, right? You should be picking up the boy ID, and this boy ID should be equal to, I'll tell you an easier way, just because the names are so big. And it should be equal to the boy ID of the other table. Make sense? So the boy ID of this table should be equal to the boy ID of the other table. You can reverse it, doesn't matter. And there is another condition. What is your second condition? From your second table, the TBL toys, its toy ID should be equal to the toy ID of the second table. That's exactly what we did, right? I said pick up the 4 from here, go and search it there. Pick up the 1 from here, go and search it there. This inner join is called an equi-join because notice your conditions. Your conditions have the equality sign. So when your conditions have the equality, you're checking the equality of them, then we say this is an equi-join. It's called an equi-join. So equi-join is, what is an inner join? You just use some conditions. I've used the conditions. This is an inner join. So till here it was a Cartesian product. If I didn't say this was a Cartesian product. Except that I didn't write Cartesian, I didn't say cross join, I said inner join. So inner join is just a special cross join with conditions. If the conditions have equality involved, they're called equi-joins. Just some terms. You necessarily don't have to memorize them, but you have to understand. Now, this should tell you the name of the boy and the name of the toy. So joins will always involve more than one table. There will always be some condition on which you have to join. If you don't give your condition, then the purpose is lost. And then the fields that you want to pick up from whatever. So was it called boys or toys? Maybe it's just a boy and a toy, not toys. Sorry. Right? It was called boy and toy. This should give you which boy has which. So boy ID 4 has 1, 3 has 2. So this is not what we want to see. We want to see their name. Who wants to see this? Nobody, right? Now run it. If everything syntax-wise is correct, and I have not messed it up, look at your last one. There it is. That's exactly this table, but definitely in a much better form. And it picked it up from here. 4 and 1. 4 was Davy. No, sorry, 4 was Richie. And Richie in 1, hula hoop. So somewhere here you must have Richie as a hula hoop. There it is. So we don't know about the order. You can always order it by if you like, right? But otherwise, how many do we have here? 1, 2, 3, 4, 5, 6, 7. And you should have the same number of records here, 7. Right? Works? So this is a join. This is a join. This is called an equi-join. Just because your conditions are equal. Instead of the word on, you can also use where, but the norm is on. The syntax is on, but where will also work, right? Where will also work. I can make it easy. I will make it easy. Don't worry. I mean, I'm just giving you the full forms first, and then we'll go easier. That's one way of doing it, right? Now, just so that you know, the easy form of this. Another way you can write it. I don't want you to see the easier form first, because then, of course, you don't want to go the tough form. But anyway, we will stick to easier one. Just copy and paste. Just copy and paste it for a minute. And instead of the word inner join, remove it. Just remove it. And put commas. That's the easier way. You put a comma. You put a comma. Who wants to write the word inner join? Right? And now you cannot use on. You have to use where now. So when you use comma, make a point. Cannot use on. You just have to make this point. We cannot use on. Okay. So this is the easier form of writing that query. So instead of the word inner join, just put commas. Commas replace the word inner join. But we can't use on. Then now we have to use where. So with the inner join, the syntax is on, and where can be used. Here you cannot use on at all. So definitely we will stick to this form. Make sense? All I did was I just combined the three tables. Instead of the word inner join, I put commas. This should work too. You should have the same answer. Same answer. Right? So that's inner join. That's an inner equi-join, because your conditions are equality. If for whatever reason it was not equal or greater than or less than, like here it doesn't make sense, then it's not called an equi-join. It's just not, it's called a non-equi-join. Okay. Now the same thing, again, do a copy and a paste, please. We just did it, right? If you like, there is a replacement. The replacement is this. You can again use a join. The join, instead of the word inner, use natural. I'll tell you what is natural. So you have to know these because they exist. Okay, so what is the difference between a natural join and a inner join? Do you see something? There is no condition. A natural join will automatically do an equi-join on same named fields. Fields have to be same named. Right? So a natural join, it's another inner join. What does it do? It automatically performs an equi-join. We just did what an equi-join was. On same named fields. And we are okay because it's called toy ID here, it's called toy ID here, it's called boy ID here, it's called boy ID in the other table also. So if you like, you can do this also. So instead of the word inner join, I replaced it with natural join, and I don't give a condition. The default conditions are exactly what you had here. These are your default conditions by default, but I removed them. Why? Notice the name of the field in boys was also called boy ID. In boys have toys is also called boy ID. So if you have an equi-join and the fields are have the same name, then you can save yourself time by just saying the word natural join. You don't have to put the conditions, but the rule is names are same. And remember, that's not the rule generally. You don't have to have same names. So maybe you can't use natural join if the fields are not named the same. If they are named the same, you save yourself some typing. This will also give you the same answer. Same answer. So you've learned an inner join, equi. You've learned another inner join with commas. And then you've learned the natural join, which is an equi inner join. And it works if and only if the fields have the same name. And it will work for us because we have the same name. Done? So you've learned inner join. So definitely, I mean, I am not saying you have to do it. I'll stick to this format, the easier form. Why? Because I need commas. And then, of course, in most cases, I'll have to do conditions. Here it's equality. Maybe I have to do unequal, whatever. So whatever makes sense to you, use it, guys. It's up to you. Whatever makes sense to you, use it. If a natural join is more, it makes more sense, sure, go ahead. I stick to this comma just because then I'm completely in control of the conditions I'm giving. I don't have to think, oh, are the field names different? I don't have to think, is it equi or non-equi? I just do it, right? So choose whatever you like. Okay, are we okay? So we are learning how to join. You can use this information back and put it in the other tables that we just did. Okay, let's look at 4. 4 is, what is it? 4 is a join. 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 Now, the 4 and the 5 are a different kind of join, and they're called left, and they're called outer joins. So we have inner join. In inner, we have equi and non-equi. And a special kind of inner is the natural join, right? All names, put it in your head. Just put your names in your head. Now let's look at this outer join. What is this outer join? They come in two flavors. I've said use a left outer join. I've said use a right outer join. Let me tell you what they are. They're like a join, but they work a little differently. This is how outer join works. So depending upon, it's called left or right. So you have a left table and you have a right table. So you're writing two table names. The first one is left, the second one is right, right? So how you write the names is important. So it says, and they're usually for questions like, which toys are not owned by somebody? So think logically what you are trying to do. You're trying to say that in this table, can you find me a boy who doesn't have a toy? So it's kind of a opposite of it. So instead of looking, so you are saying, oh, 4 has a 1. Okay, job done. So the boy 4 has a toy. So he cannot come in the category of a boy that doesn't have a toy. 3 ruled out, 6 ruled out, oh, all have been ruled out. 1 ruled out, 5 ruled out, 2 ruled out. So this is what it does. It will take this table, right? It will take this table where it wants to find out who is not there. It will take this table and we will combine it with, we will join it with, say, boys table, okay? And we'll say, do you have a partner? Do you have a partner? Do you have a partner? If a record here in the boys table doesn't have a partner here, that means that boy doesn't have a toy, right? So you take the boys table, you go through each boy. Boy, are you in this table? Gone. Boy, are you in this table? Gone. Boy, are you in this table? No. Oh, you don't have a toy at all. I will spit out here. That's what an outer join is. So let's write it and then let's word it. Okay, so write. We'll do this one and then I'll leave the next one maybe to the next class if you're too tired. It's not a big job. Left and right are just the opposite. Okay, so write with me. What are the two tables? Okay, so let's say select. I'm only interested in the name of the boy. Maybe it depends. I mean, doesn't matter. Okay, so let's do a left outer join to find a boy it doesn't have. Okay, so now I'm trying to write something new for you. Just follow me, okay? To make life a little easy. I'll tell you why it makes it a little easy. Now, what's this B dot? Give me a minute. Let me just complete it. Okay. From. Remember that table which was called boys? Since these names become very big as you go on, you can give it an alias name. I'm calling it B. So B is just an alias name for a new table. That's all it is. Just a different name, making life easy. If you don't want to, sure, go ahead and just leave it, right? Doesn't matter. It just becomes easy. Okay, so let's write it. Okay, so I need the boy's name and the second table that I need. What was this called? Boys have toys. Okay, so we'll have to think for a minute. What do we need as a left table and what do we need as a right table? Okay, so let's do this. It's called outer. Let me write it in caps. Outer, right and left. Oh, I'm doing a left, so I'll have to change it. Doesn't matter. I just have to change my table name. So I'm saying, and my second table is, I just haven't written, since the question is on left, I'll have to be careful. What was that table? Boys have, there it is, boys have toys, there. The table has to be placed at the right position, left and right. Okay, so this is BT. I'm just calling it BT. Boys have toys. Okay, boys have toys. Okay. Oh, wrong place. Left outer join it is called. That's why I'm saying it's a squiggly. As soon as you see something squiggly, think for a minute. Have I made a mistake? Okay, what is your right table? The right table is called, this boy doesn't have a toy. So this is one table. This is the boys table. You could actually do it two ways, guys. You could do it two ways. Okay, let me show you both ways. Okay, let me show you both ways. You can pick up both. Both will work. You'll tell me yourself when I do it. You can put the word as if you like, if it makes your life easy. You don't have to. You don't have to, like your alias names, you don't have to. So, okay. I'll show you both ways. It can be done both ways. Okay, this is what I'm doing. I'm taking the boys have toys table. I always need it. I'm taking the T table. Let's do it with B because we've talked about B. I've talked about B with you. Let's see if it works. I'll do it both ways for you. Okay, so pick up this table. It's just a little tedious, nothing else. Pick up this table. And I'm going to combine this table with the boys table. And I'm just going to show you the select statement first. And then you will tell me what needs to be done. The condition. Where? Okay, how are you joining it? BT dot, just so that I don't have to write the full name. Boy ID is equal to the B's boy ID. Okay. Again, you can use on or where. Okay. And for a minute, just let's leave it. Oh, maybe, what isn't it like? Let's see, what isn't it like? It would be nice as in Eclipse, you bring it here and it tells you what the error is. TBL BT is this, B is this, B boy is this, left outer join. I don't know what syntax wise it's not liking. Let's see. Do I have an error? Oh yes, you have an error in your SQL statement. Oh, that's the help you're giving me. What is the syntax error it says? TBL toys have boys, TBL toys as B. I don't see. Okay, let's try. I'm sure where will work. In outer joins and inner joins, both where and on work. Where seems not to be working, but it does, I remember. Anyway, at least for syntax wise, I'm taking care for now. It's giving still the same syntax error?
No, it's not the same.
Oh, it's the same. Okay, another, but at least. Okay, let's see what the error is.
You're asking for the boy ID in toys.
Oh, I get it. Yeah, so now it's a logical error. At least we know what the error is, right? It's better to have an error which makes sense rather than just saying syntax. Okay, what is it saying? Look at the error. Makes sense. It says, here, look at it. It says unknown column B dot boy in field list. Oh, because I forgot to change this guys. Remember I was saying I'll use the boys table first. Here, okay. Okay, that makes sense. So that's making sense. Okay, good. Oh, you know what? I want to show you something. Let's do a star. I'll go step by step. Because if I just give the answer, then you won't understand what I've done. Okay, there it is. This is what it has done. Oh, it has done an equality. What else is that? Okay, so this is your first table, boy ID, toy ID, boy ID, toy ID, boy ID, toy ID, and so on. And it has combined it with one could be combined. Let's remove something. There is no boy with no other letter. 1 with 1, 2 has been combined with 2, 3 with 3, 4 with 4. So notice how it combines this 1 with both tables, right? That's how it combines. So it picks up the first table and looks for a partner in the second table. And here, unfortunately, they all have partners, right? So every boy has a toy. So let's remove something to see how does it work. Okay, so remove something, guys, from your table. Otherwise, how will I show you? Take a boy that doesn't have a toy. Every boy has a toy, looks like.
Or you can add a new boy.
Do we have a boy who doesn't have a toy? 1, 2, 3, 4, 5, 6. All boys have toys. Okay, so remove a record. Maybe the 6th record, the Billy guy. Let's remove the Billy guy here. Just because it's the last one, we'll make it a little easy. Here. Okay, now Billy has no toys. Okay, Billy now has no toys. Run it again. I want to show you what is happening in that table. Okay, run that table. Run that query. So, since there was no 6 here, there is no combination with 6 here. Oh, now we have to, okay, so how opposite? Oh, how do I find out which boy doesn't have a toy? So it combines something. If it cannot find a partner, it should be giving a, give me a minute, guys. I haven't solved the purpose. I want to show you something and that something is not coming up. Okay, I think I can do this. Give me 1 minute. Give me 1 minute. You are the left. You don't make changes. Let me do it and let me be sure and then, okay. As soon as I get that answer, I'll know. There it is. I have it. There. I have it. 6 Billy has no partner in the other table. All I did was I changed the sequence of the table. 6 Billy has no partner. Okay, now come back and see what I've done. Okay, this is exactly what I've done. And we'll see the result in a minute. Okay, let's see it together. So you make sense what is left outer join doing. A little more. Okay, now pay attention, please. Now I have what I wanted to show you. I did a select star because I just wanted to show all the fields. And now notice what I did. I said, pick up my boys table. Your boys table had a boy and a boy ID. So you can make out, but there it is, the first 2 rows, the columns. So pick up the boys table and let it say hello to the boys have toys table. If you can find a partner, good. 1 finds a partner, 1 finds a partner again, 2 finds a partner, 3 finds a partner, 4 finds a partner, 5 finds a partner. 6 doesn't have a partner. What happens to the fields of the other table? None. Right? Now, if I only display those records in which the boy ID is null in the second table, I have my answer. You see what I was trying to do? I was trying to combine 2 tables and the boys are saying hello to the boys have toys table, but 6 Billy, he didn't have any toy. So he didn't find a partner in the other table. And how do you know it doesn't have a partner? It will have null in this field. So now if I complete this, and which records do I want to show? Which records do I want to show? Which boys don't have a toy? Wherever the boy ID is null or the toy ID is null in the second table. Okay, so what do I say? On this, and now, what do I want to say? Give me a minute. Use a left outer join. And show me those records where, what is the boy ID? What is that table called? BT dot boy ID. You can pick up any field. I'm just picking up the boy ID field because it's the easiest to pick up. Oh sorry, not equal, is null. There. Therefore, it wasn't taking where there because in on and where we have to now differentiate, right? So what did I say? See, now which records am I picking up from here? Wherever the boy ID in the second table is null. So I did not have a where condition before. I just joined the 2 tables. I took the boys table and I said, say hello to the boys and toys. And this is important. This sequence is important. The left table is looking for partners in this table. Therefore, it is called a left outer join. The difference between left and right is all you will do is you will swap the table names and it will work the same. So when I say a left outer join, the left table, the table before the first table in the sequence is picking up a record and trying to find a partner in the second one. If it can find a partner, join. Notice how 1 has joined with 1, 3 and 1 has again joined with 1, 5. If you cannot find a partner, then you won't have a partner. You will have null in it. Now try it. Now let's see what happens. I only have 1. If I'm only interested in the name of the boy, what should I pick up from here? B dot boy. And I have his name. I have his name. So the outer joins are trying to work a different way. The outer joins are saying, try to look. So there is an outer left and right, doesn't matter. So there are 2 tables that are kind of involved. And every record in the first table is picked up. So where is the boys table? Okay. So one says 1, do you have a partner for me here? it says, yeah, there it is, 1 and 3. 1 will combine with 1 and 3, and 1 will also say hello to 1 and 5. Why? Because the combination is the boy ID. Notice how I have said combination is on the boy ID. So everybody says a hello. So 1 says a hello, 2 says a hello, 3 says a hello, 4, 5, 6 doesn't find a partner. When 6 doesn't find a partner here, what happens? It will have null in its fields, in this field. It doesn't find a partner, it will put null in all the fields. We're not interested in all the, you can check any field you like. I just picked up the boy one. And now I show that record, but I don't want to see the whole record. I only want to see the boy's name. Only see the boy's name. And run it again. And then poor Billy has no toys. Write the same thing using a right outer join. That's the next question. I'll take 1 more minute. I've already taken 9 of your minutes. Pick the same thing, put it here, change the left to right. We'll work more on it, don't worry. Change the left to right. This table now comes to this side, okay? And this table goes to the other. That's the only difference. There. So the left outer join says take this table and compare with this table. The right outer says take the right table and compare with the left table. It's the same thing. Right? It's the same thing. I've done the same thing. In one, I've used the word left outer join. In the other one, I've used the right outer join. So let's try that again. And your last 2 answers should be Billy and Billy. That's the only difference between left and right outer join. Nothing else. The left outer join takes the left table and tries to say hello to the right table. The right outer join takes the right table and says you say hello to this. And the left and right are like this, right? Normal left and right. So that's left and left. So the right and left just say which table says hello. That's all. So here the left table says hello and here the right table says hello. So it's the same thing. I've written it the same way. I've just changed the positions of my table. That's an outer join. So outer join comes in 2 flavors, a left and a right. The only difference is one picks up the left table, the other picks up the right table. The left is before and right is after. Right? So you should know inner joins. You should know outer joins. You should know natural joins. The Cartesian cross join is not a join. It is just like there are no conditions at all. It's just everybody saying hello to everybody. So if you now know the terms, we'll stick to maybe commas for the inner join because they are just easy. And for outer joins, there is no comma. You have to write them like this. So depending upon the question, you will say, do I need an inner join? Do I need an outer join? In the inner, can I use a natural join if the field names are equal, same, or can't I? It's up to you. Okay. So this is just an introduction to joins. Now our job will be to do joins and joins and joins. So for the rest of the 3 weeks, unfortunately, 2 for you, we'll have to cover joins and subqueries also. So I have to think of what to do. If you could attend my Thursday, I mean, I don't know, like I have no clue if you guys are free on Wednesday mornings. What about it? Wednesday, I have the same class at 8. If I can combine my 2 sections, that will kind of be less burden on me. The only other thing is I'll give you, say, here, read. I mean, I have to do it, right? You'll just have to do it at home. I may just give you ready-made samples and say, do it. So how many of you can attend the Wednesday morning class? Only Ratan. Other people have classes. Oh, well, can't do anything about it. I have to have, I mean, I can teach extra. I don't mind teaching extra, but I have to have a time slot. I don't mind. If Monday is a holiday, I can teach some other day. I can do Tuesdays. I can do Thursdays. I can do Wednesdays, of course. So I don't know.
What Monday is a holiday?
1st of August, I think. That's what I've been told. I haven't even checked it up. Yeah, so another week and then 1. Yeah, 1st August is a holiday. Try to wake up if you can. That will be your like a second last class. You know what I mean? Like, oh, well, if you can think of a solution amongst yourself, sure, let me know if you have a free class where you all can come. Exactly. You see, then I'll miss a class, then you'll have One more. No, after that you have one more and then you have the exam. You have one more. But in that one, I can't cover 6 hours. The only way I can cover it is I give you this, I mean, I give you something I've already done and you read it. And joins and subqueries are not that easy.
Probably post a YouTube video.
Oh yeah, that's up to you. I tried that last time also when you had a first Monday off somewhere in the beginning of the semester. I tried